This is the last topic for database. What is a database?
All the table.
Yeah, a database is basically a table with different attributes. The top part are called attributes, and the rows are called what? Wendy, what are the rows called? Entities. Okay? And database, why are database important there, Chad? Why do we use database? What are some good things about database?
They can store data easily and they are quick.
Yes. Database is easy to find data, sort data, because you can use this thing called SQL. SQL is it's like a language for database where you can find things like select things and add things, okay? Yeah, you can just independently work that. I'm gonna teach you here, okay? So, today, we're going to learn about normalization. Now, why do we do normalization? Normalization allows us to improve data redundancy and also improve the data integrity. Because, for example, let's say I have a field here, and I have my Tom Hill. I put two pieces of data in there. But if I want to find, this is the first name and last name. This is the first name, last name. But if I want to only return Hill, I can't return him because he's in the E on the cell. And so what normalization is you want to make sure that the data, you can easily access everything. So normalization is like splitting the data into different columns. You can make another attribute. Because if it's all in one thing, I cannot just find Hill. I would have to return both names. But databases can't really cut things, and that would waste time, and so we need to normalize, okay? And so there are 3 normalization steps to do. There's first normalization form, second, and third. And you already wrote down the definitions here, so I'm just going to give you some juggaleads in that, okay? Let's watch a little video to understand what this is all about. Because my throat is not very good. We're going to watch on YouTube an example of normalization, and then we'll have some examples. Okay. So this is grade 11. Normalization. Just bear with me. Oh, okay. And also you can always practice database on SQL. W3 school is very useful, okay? All right. Where did this open? I think it's right here. All right. So let's have a watch.
While you're watching this Monday.com ad, Emma clicked the star and Monday Sidekick just planned her entire campaign, scheduled every milestone, and briefed the team. Bring those leads.
Hello and welcome to this beginner's guide to first, second and third normal form when looking at database normalization. So let's get started. First normal form. This one is nice and simple. All rows must be unique and all cells must contain atomic values. Well, what does that mean? Well, it's really quite simple. Each row in the table must be unique, and therefore there cannot be any duplicate rows in the table. So you can't have 2 different rows where all of the data contained within those rows is identical. And we'll give you an example in a minute. And each cell must only contain a single value. So you can't have a cell in a table that has a list of values in that cell. That's a no-no. And finally, each value should be non-divisible, which means that if you've got something in a cell, you can't break that down into further sensible parts. So let's have a look at an example of each of those. So each row must be unique. So let's have a look here. We've got a table of takeaway orders here, and we've got for each takeaway order, we've got a customer name and a customer order. So for instance, Bob Jones ordered here, he ordered burger, fries and Coke. Fred ordered nuggets, lemonade and fries, and then Bob also ordered burger, fries and Coke. Now that's fine, apart from we can't tell the difference between this row here and this row here. So we have no idea, for instance, which order was ordered first. We've got no idea at all. So we need to change that because they need to be uniquely identifiable. And the way we do that, nice and simple, is we just add an order ID column. So here, order ID number 1, well, that was Bob Jones, and he ordered his favourites there. Order ID 2 was Fred's, and he ordered all those. And then the final order was Bob Jones, and he ordered his favourite order again there. So because we got these order ID, that row there is now no longer identical to that row there. There we go, good. So that's the first part of first normal form done. Second part, let's have a look. Each cell must only contain a single value. Well, yep, as you can see here, this cell here doesn't contain a single value. It contains 3 items, a burger, fries and Coke. In fact, all of them do. So these ones here, these in this area, the actual order ID, they all do. So that's no good. So what we need to do there is we need to move those into a separate table so that each row only has 1 item. Let's have a look. So it's going to look a bit like that. This table here has an order ID in 1 column and the item corresponding to that order ID there. So order ID 1 has a burger, order ID 1 also has fries, and order ID 1 also has a Coke in there. And as you can see, each item in this table now is unique, and there's no multiple values per cell here. So that's sorted now. So that's the second bit. Good. Third thing, all data must be atomic or non-divisible. Well, what's the problem? Well, if you ever look over here at customer name, Bob Jones, you can actually see that Bob Jones isn't atomic. It can be divided further into into his first name and last name, and that's no good. Okay, because that makes it some kind of composite value. That's no good. It needs to be separated out because those are different things, and it looks just like that. So you create a column for their first name, a column for their last name, and you just put them in separate cells. It looks like that. Good. So that's how you put a database table into first normal form. So now let's move on to second normal form.
All right, we're just going to pause it.
Second normal form.
Okay, so what happened was Bob had like fries, hot dogs or something, right? He had pizza and hot dogs and fries. Okay. What is the problem here, Chad?
They are not in order.
We have too much data inside the order. Agree or disagree? Yes. But the other thing is, Bob ordered twice. So we need to make sure that they're uniquely identifiable. So first, all fields must be atomic. 1 data in 1 cell. They must be non-divisible. That means that you can't have 2个东西一个 cell, okay? And it must be identifiable, uniquely identified. So in this case, we would have to make an ID because Bob happens 2 times. We know male primary key. right? So we have to make a primary key. And how do we fix this? Well, you can break this up into the table. This table here, we can break it fries, hot dogs, and this is the order number 1, and then 2, and then 3. Okay, you can see that now we have 一个东西 in one cell. Okay, this will be pizza, and this is hot dogs, and this is fries. Okay, no problem. 先那个举个例子 Under 1NF in your notebook, show this. This is not okay. This is not okay. We have fries and hot dogs. This is not okay. There's 2 cells, 2 items in one cell. These we have 2 names. We have 2 names who we can't identify. Who's Bob? We needed to add the primary key. And this is the fix. This is fix. And this is the fix here. Okay? Give a jugaliza. After that example, we will do the second normalized form. This again, normalization is to reduce on data redundancy. And also, it makes the integrity of data. For example, I can't find Bob because there's 2 Bob with that order. Also, splitting the first and last names and things like that. We'll get to that. But let's say you wanted to find Bob's last name. If we put 2 datas in one cell, we can't just find the last name. We would have to return first and last name. So it's dividing it down smaller. And that's what we're going to do next. Do you have that example? Wendy, you're okay? 1F? All right.
5.
And I got that. Hey, Wendy? Okay, so this is step 2. Let's have a watch.
Not quite as much to it. All you need is there are no partial dependencies. Well, what does that mean? Well, what it means is, first of all, that the table must first be in first normal form. So you can't have a table that's in second normal form until you've gone through all those rules that we just did from the previous one, from first normal form. It must do those first, and then we must have all non-prime attributes should be fully dependent on the candidate key, and it's fully dependent on the whole candidate key. Well, what does that mean? It sounds a bit complicated, but it's not. So let's have a look here. We've got a list here of students, so the student ID, the course ID that student is doing, and how much that course costs. So here, this student, they're doing course, so student 1 is doing course ID number 1, and that course costs 500. And student, so student ID 2 here, he's doing course 3, and it's 750, and student 3 is, student 2 is doing course 3, and here student 3 is also doing course 3, and it's costing 750. Well, what's the problem with this table? And the problem is that the course fee has got nothing to do with the student ID. So the course fee is a set fee that only depends on the course ID. So this particular course, course 1, costs 500. Course 2 costs 1,000. Course 3 costs 750. And as you can see here, it doesn't matter whether it's student ID, student 2 is doing course 3 or student 3 is doing course 3. For either of those students, it costs 750 for each. And that's because the course fee has nothing to do with the student ID. Now, it's important here to note that the course fee is not dependent on the student ID, and the student ID forms part of this composite key here of student ID and course ID. So this is the composite key, but this bit is only dependent on that bit and it's not dependent on that bit. And that's where you get this partial bit, because it's not dependent, it is dependent on this part of the composite key, but it's not dependent on this part.
I'm just going to pause it. You see the problem with this is course 3 costs $750, right? And course 3 is 700. This is long fade, deep, this is wasting data because it's beyond the data. Why do I have to 保存 750 two times? This is data redundancy. 我们有 beyond the data, right? We have 750 and 750. So we can actually make it 简单一点. So let's see how they can make it fix this
key. So that's where we get the partial part of it. So what have we got to do to fix this? Well,
rocks. I'm writing a paper on them. This is a lasting sand between me and break, and I need...
Nice and simple. All we do is we move this information to a separate table, just like that. So we have a table about course fees, and each course ID has a course fee attached to it. Course 1 is 500, course 2 is 1,000, etc. And
so, how many times does 750 happen here there, Chad?
The other table, we pretty much keep the same.
$750.
One time.
One time. 之前, before, how many times?
Before 2 times.
2 times. So this is more simple. It simplifies. So let's write down this example. Okay? So on the whiteboard, I'm going to write down the answer. So example for this guy here, okay? Can I erase this? 这个你 copy 好了吗?
Yeah.
So I'm gonna, let's write down the example of this one. So before we have student, then we have course ID, and then we have the fee for that thing, right? And so before we had student 1, course ID 2, then we have 3, and then we have student 2, okay, 2, 3, okay. This is 5, 5, 3. Okay, now I'm going to write down the fee. So the fee for 2, let's say, is $200. Course ID 3, we'll just say it's $300. This is $500. This is $300 and $500. Chad, what is the problem with this?
There has the 500 and 300 have been happening 2 times.
Yeah, because this is exactly the same information. So this is called data redundancy. Let's write down this data redundancy. Okay. So how can we fix this? Well, we can fix this by making 2 tables. One table is courses. We have student ID. And then the course. So one table will show the student. and he will show the course. So he's doing course 2, course 3, course 5, 3, and 5. Okay? And then we can have the fee. You can have the course, and we have courses 2, 3, and 5. We only have 3 courses, yeah? And then the fee right here, we can reduce this because course 2 is $200, this is $300, and $500, right? So we can fix it by making 2 tables, and then we can reduce the redundancy. Okay? No problem? Okay, that's it. That's the second fix.
Same. But we don't need this extra course fee information. We just get rid of that column, and we only have the student ID and the corresponding course ID. So student 1 is doing course 1, student 1 is also doing course 2, student 2 is doing course 1 and course 3, etc., etc. So that is no partial dependency. It must be fully dependent on each of these parts of the composite key, if you've got one. Okay, so that's second normal form. Third normal form, no transitive dependency. So it's similar to the previous one, but we're not talking this time about the primary key or the composite key. We're talking about something else. So, just like when you tried to put something into second normal form, it had to already be in first normal form. Well, third normal form is the same idea. What you need to do is it needs to be in second normal form. But of course, that also means that therefore, if it needs to be in second normal form, it must also be in first normal form because the two go back. So anything that's in third's got to be in second, and obviously anything that's in second's already got to be in first. So it needs to tick all those other boxes. It can't be duplicates, it can't be divisible, it can't be multiple values. It also can't have a partial dependency. So all of those, and then it must also do this third, this other item here, which is no transitive dependency. Again, sounds a bit weird, but all it means is that all fields must be only determinable by the primary or composite key, and you can't determine any of the fields by other keys in there. So what does that mean? Well, let me show you a nice simple example. Here we go. So here we've got a list of tournaments that I've pulled from Wikipedia, and here it's there's the tournament name, and that's the year the tournament was in, and then we've got the winner of the tournament and the winner's date of birth. So this works well. It all fits through to first and second normal form. But there is a problem with this table, and the problem is that you can determine one of these keys by looking at another one of those keys. Can you see which one it is? Well, nice and simple. It's here. You can tell what the winner's date of birth is by going to the winner's name. So here you can go. You know that the winner's date of birth is this date of birth, because that's his name, okay, and he's got that name. So although it's not dependent on these bits here, you can't tell the winner's date of birth from the tournament name or the year, you can tell the winner's date of birth from the winner's name. Okay, so that's no good. So this information, as it stands, can't sit inside of the table. So what have we got to do? We've got to fix that, and you could do that by having a separate table of winners here. So for instance here we've got the tournament name, the year, and the winner there, and we have a separate table that says, okay, Al Fredrickson, his date of birth is this, and we split the two and this works because here the winner is dependent on the tournament name and the year, because that tournament happens every year, so you can't work out who the winner is just by the name of the tournament itself. And there are multiple tournaments in one year, which means you can't determine the winner just by looking at the year. You have to use both of the name of the tournament and the year in which it was held in order to work out who the winner is. So that fits perfectly. And then over here, again, the date of birth corresponds to that particular winner. There you go. Okay, good. So that is first, second, and third.
So this is the last example. The last example is when you have, you can determine one cell from another cell. Okay? So for third normal form, for example, we can.
What's the normal form mean?
It means that if you can determine a field from another field, like this, we have the winner and his date. You see, we have the winner and the date. And so if I were to give you this data and hide, let me show you. Can I write on this? I think I can. Yes, I'm gonna write on the screen here. For example, if I were to hide this and ask you, who was born on the 21st of July, 1975? Can you determine this?
No.
Yes, you can, because it's right here. 这个是一样的。
Oh, yeah.
So I can determine this and this because this person will always have that. So if they're listed twice, this is like a link. So we need to, that's not okay. We need to break that up. How to fix it? Well, make two tables. Make this one table and link it to another table. Okay? So you can break this up into two tables where you have the name of the determinant right here and the year. That's okay because these are separate. They're not linking. There's no data connection between those fields. And over here, we can put the winner and the date of birth. Okay, that's it. That's the thing. You can't use two fields to link the data. In this case, there was some linking going on. That's it. Your schoolwork. It's 5.5. Okay? So, let me just stop this right here. Your homework is 5.5. What is the purpose of normalization, Chad?
Normalization used to move data redundancy and improve data
Integrity, exactly. And now,
how to speak it clearly more?
To remove data redundancy and improve data integrity. Now, Chad, is this table normalized? Yes or no?
Yes.
No.
No.
It is not. Why?
Because he said it's wrong.
No, but why?
What?
Why is this data not acceptable? Why? Look at this data. It's not normalized. You need to normalize. What is wrong? It's not atomic. What does atomic mean? Look at this. Is this okay there, Chad?
I think this is okay.
It's not. You cannot put more than one data in the cell. This is called a tuple. English math is different. You need to split that up. Remember how we talk about that?
Yeah.
So you can't have more than one subject in one cell. So you need to tell us 4 things. Why 这个有错误? This also 没有 ID. He has no primary key, right? So you need to write down here. Doesn't have a primary key. He has too much data in one cell. Look, 一个 cell, is this okay?
No.
这个是 OK， 是一个东西。这个有1、2、3个东西。You can only, atomic means one cell, one data. Okay? 你写. So that's the answer. It's not atomic. 还有什么错误? There's a problem here. Subject. This is a problem here. Subroutine. You can't have this as well. They're not atomic. There's no unique identifier. There's no primary key. Okay, so just work on that. This is your score.